Hello all. Today we're going to be showing you how to find the value of an integral using a Riemann sum and a limit. So let's go ahead and get started. We'll start off by writing down what we know. So first thing, we know what the function is. The function is just going to be 2 plus 3x. We know the function is going to be over the interval from 1 to 3. Because of that, we also know we are going to be using a right-hand sum. So we're using the right-hand Riemann sum with n rectangles. Now, it's not necessary that we use a right-hand sum, but in class we've been doing it this way, and lots of people tend to do it this way. So this is our choice, but we know we're using that right-hand sum. So after we've made that decision, we also know what delta x is going to be. We know delta x, if there's n rectangles and the interval is of length 2, it's just going to be 3 minus 1 over 2, and delta x is going to be 3 minus 1 over n. I apologize. It's going to be 3 minus 1 over n, and delta x is going to be 2 over n. So we know the value of delta x. We also know x0 is going to be 1. It's the left-hand point of the interval. And we know x1 is going to end up being just the left-hand endpoint plus 1 value of delta x. So it's plus 1 plus 2 over n. So there's going to be x of 1. We continue this pattern and we can figure out what x of I is going to be. It's going to be 1 plus 2 times I all over n. All of this material is going to be necessary for figuring out what the final value of the sum is going to be. So let's go ahead and try to use this information that we've got here to find out what the sum is going to be. So we'll start out over here. The general formula for R sub n, for the right-hand Riemann sum with n rectangles, is going to be f of x sub I times delta x. Okay, so there's the general formula. We know what a lot of these values are, right? So let's go ahead and write them down. From now on, I'm going to be leaving out the subscript and the superscript on the summation sign, but I'll add them in whenever it's appropriate. So we know what x sub I is going to be. X sub I is just going to be this 1 plus 2i over n. Delta x is going to be 2 over n. And there we go. So let's go ahead and use some of our algebra knowledge to make this simpler. We're going to bring the 2 over n out. We're allowed to do that. And we're going to go ahead and put this 1 plus 2i over n into the function f. And we know what the function f is. It's 2 plus 3x. And so this is going to be 2 plus 3 times 1 plus 2i all over n. Well, let's clean this up a little more. So we have 2 over n sitting out here in the front, and we have the sum of, I think I am short one parenthesis here. There we go. So we'll go ahead and we'll take this sum. This is going to be 2 plus 3 plus 6i all over n. And there we go. And so clean it up one last time. And this is going to be 5 plus 6i all over n. And there we are. So this is a good position to be in right now. Next up, we can take this sum and we can split it. And this works very nicely. It splits over the 5 and the 6i over n. And after it does that, we can realize that this sum of 5s, this is a sum where I goes from 1 to n. So this is really just 5 plus 5 plus 5 plus 5 again and again. So we're just going to be able to write this, instead of the sum of 5s, we're just going to write this as 5 times n. Not a problem. We're also going to take the 6 over n that's attached to the I here, and we're going to move it to the front of the summation sign. And this is just going to look like the sum of I, where I goes from 1 to n. At this point, we can bring in our outside fact here. So let's see if we can scroll down. Give us a little bit of extra room. So fact. We know that if we want a sum where I goes from 1 to n, we're summing all the i's, we know this is going to be n times n plus 1 all over 2. This is one of those things we announced in class, and we're going to use it here. So let's go ahead and write it in. We have 2 over n times 5n plus 6 divided by n, and this sum of i's is now turning into an n times n plus 1 all over 2. And we can simplify a little bit from here. We'll go ahead and leave the 2n out for now. And the n here is going to cancel with the n on the bottom. The 2 and the 6 are going to cancel, leaving us with just a 3 on the top. And so this is just going to be plus 3 times n plus 1 all over n. Oh, scratch that. 3 times n plus 1. That's it. Now we'll go ahead and we will multiply the 2 over n through. And when we do so, we're going to have 10 for the first term, and this is going to be 6 times n plus 1 all over n, and this is going to be equal to Rn. So this is the final equation that we have for Rn, and it's a lot simpler than what we started with. There's no index I, there's no sum, it's just easy. So if I wanted a rectangle with, if I wanted an estimation, a 20 rectangle estimation, not a problem, I've got it right here. So let's go ahead and find the area. We've got a nice version of the right sum, so let's find the area. So then the area is and the area, remember in class, we just said is going to be the limit of this right-hand sum as we allow the number of rectangles to get really huge. So we'll take this limit. This is going to be the limit of 10 plus 6 times n plus 1 all over n, which is just going to be so the limit is not going to do anything to the 10. This is going to stay as 10. The limit is going to take the 6 times n plus 1 over n, and that limits to 6. We have a total of 16. So there we go. Hopefully this is helpful to you. If you have more questions, you can always find me in my office or in the classroom. Anyway, good luck and happy mathing.